Hello and welcome. If you're first time here on my channel, you know I've been doing a lot of videos on Azure Pipeline, talking about YAML driven pipelines and how it's beneficial to have pipeline as code, showing you real example of doing that with .NET Core. In this video, I'm going to change the gears a little bit and talk about cloud optimization and compliance. And this isn't a video out of the blue. This is a video which will hopefully allow you to understand how you could take your cloud investments even further by optimizing and at the same time being able to go faster using DevOps, but not go fast over a cliff by ensuring that you're using the right compliancy measures and tools to make sure that your cloud is safe and secure without having to invest a whole lot of money into getting paid DevSecOps tools. So a very light touch video. I'm going to mostly cover a few concepts and then get into a demo and show you hands-on implementation of how to do this with AWS as well as Azure. So, an interesting fact to kick off the presentation is the total spend on cloud in 2020 is forecasted to be 226 billion. That's a lot of money, right? And that's just not the spend of cloud by one segment of the industry. It's the total global cloud spend that's anticipated. It's not just for one provider like AWS or Azure. It's the net total cloud spend globally across all cloud providers. But nevertheless, this is a massive figure. Now, interesting enough, 47% of enterprise customers are doing cloud migration for optimizing cost, and that's the key driver. And I'm not saying that that's the only driver, but that seems to be the key driver that resonates across the industry. There are other drivers like getting efficiency, getting more speed in their dev processes, but nevertheless the cost optimization is a key factor for many and most of the enterprises. However, this blows my mind that in spite of being cost efficient is one of the key drivers to move to the cloud, 17.6 billion every year is spent in wasted cloud resource consumption. And I'm going to wait a second for that to resonate. 17.6 billion worth of money every year is burned in cloud resource that's just lying there unused. And what I mean by that in this more intense drill through view is 11 billion worth of that money is wasted in resource that's been spun up in the cloud, but it's lying there idle. And about 6.6 billion of that is wasted because people just find it more convenient to provision oversized resources much more than what they need. And if we look at the split, you would see 44% of non-production environments are mostly wasted spend. Now, how many of you know enterprise customers that want to go down this route of creating multiple servers in multiple regions for when the disaster happens with never testing the second region, and they have now these two active regions running in parallel all the time? Well, there you go. That's 44% of your non-production spend lying there idle, waiting for that disaster to happen that never does. 40% of that is oversized machines that are provisioned. Again, it's very convenient for developers to go in and say, I need that 32 core VM for running my website, or I need that higher SKU of the web app or Beanstalk because that's what I anticipate my app is going to be. So people shy away from using things like auto scaling. Rather, they would happily invest more money in paying for a higher SKU, whether they need that or not. Another key point I want to get across to you is we have a lot of non-production environments, for example, dev environments and test environments that are only used during business hours, but they're left running even outside business hours, especially on weekends like Saturdays and Sundays. And that's what massively contributes to this wasted spend of 11 billion that I've been referring to here. Moving on, I want to talk a little bit about cloud computing security trends. And two facts that I want to get out through to you today is that more than half of the organizations that are actively investing in cloud today do not have systems for monitoring, managing, or securing cloud applications. And they are relying on manual human labor to be doing that job for them at global scale. And it's no surprise that human job management proves to be very erroneous and not as cost effective as you would imagine, where people are manually patching environments and they're manually managing the state and configuration of those environments, and they don't have active monitoring in place, and they still rely on tickets to be raised by users or ongoing basis looking at log files to see how systems are performing. Another important fact to get across to you is that 99% of the abused vulnerabilities in systems are already known to security and IT teams for at least a year, and yet they do nothing about it. And this is purely down to the scale and the size of security teams today, where one security professional is managing at least 10 or hundreds of systems, and they just don't have enough bandwidth tooling available to sort of act on those known vulnerabilities. And it's no surprise, right? When us as developers spin up an S3 or an Azure blob, we would just happily uncheck the encrypted checkbox on there, and we don't encrypt our data. And it's not that the ID security team doesn't find out about it. Yes, they will run a manual check or a scan once in a year, but then they don't have continuous processes in place to ensure that those vulnerabilities are addressed and closed out. Cloudcustodian is an open source cloud security, governance, and management solution. And as you can see, it's quite popular on GitHub with enough forks and stars to highlight that they're doing some interesting work. Cloudcustodian was born at Capital One, and today Cloudcustodian is actively being developed on GitHub, with Capital One being one of the many contributors to this open source framework. Now, this is a YAML-based DSL language. Essentially, that's what it is at the crux of it, that allows you to write policies to inspect the security, apply the governance, and manage and operate your cloud. Now, the beauty is that these policies can be configured to run against the AWS cloud or the Azure cloud or the Google cloud. And you could decide to run it on one account within your AWS or multiple accounts, which means they scale out really nicely. Now, because they're written in YAML, these policies, you could add them to source control, and all the great benefits of source control apply, where now you could code review them, you could pull request them, you can have multiple branches and constantly append, approve, and collaborate on these policies. And because it's all in the code, you could have a continuous delivery mechanism around them, such that these policies are run when you deploy new changes to your application or on an ongoing basis. Cloudcustodian natively supports integration with serverless, so you could have some of the Cloudcustodian policies run natively as Lambdas or Azure functions. And the thing that blows my mind is that they can natively log the outputs into Cloudwatch or App Insights and Azure Monitor, which means you could use the native features of the cloud providers for purposes of alerting, amongst many other things that you would use them for. I know I run a small risk of upsetting all my viewers who love Azure, but on the next slide, I'm going to show you a quick flow diagram of how this works in AWS. But rest assured, if you stick around for the entire video, I'm going to show you a demo of how this works for AWS, and I'm also going to show you how this works for Azure, so stick around. Now, as you can see on your screen now, the policies essentially written in Cloudcustodian are YAML files, and they could be persisted in a Git repo. Now, when you write these policies, you could run them in your local terminal environment, and or you could run them on a CI/CD toolchain. And when you run these policies, you get various switches, like the metric switch. The metric switch allows you to output the metrics from these policies into Cloudwatch. And again, that gives you the whole charting and alerting on the back of that. Similarly, the logs from the execution of these policies can be pushed out to either S3 or Cloudwatch themselves. And then coming from the other side, you could have a stream running against the log files to identify for failures or keywords that you could set up alerting on. So that flow could work both ways. Now, talking about the serverless aspect of running the policies, you could configure the policies with the right roles to run in Lambdas themselves. That could be running on a recurring basis or at schedule intervals, depending on the schedules you configure for them. Or because you're using Lambdas, you could set up certain events at which the Lambda gets triggered. And again, all of this could be real time, and you could use the queues and SQS and SES to sort of drive the alerting and the monitoring on the back of that. So I know you're probably itching like myself to see this in action. So that's all for slides. I'm going to move into a demo now. Start by showing you how to set this up, have a little play of setting up the policies locally, fiddling around and hacking away with AWS, and then start doing that for Azure. Let's go over to GitHub now, and we can see the Cloudcustodian project. There's a good description about the project, a heads up on the pipelines. If we go into the landing page for the documentation, I must compliment that it's quite well structured. You've got hot links into the docs, the examples, how to do the installation. So let's follow along. I've created an ops directory. Let's start off by setting up a virtual environment. I'm using Python 3. I'm creating a virtual environment called Custodian. Just running the command. If I ls, I can see that my virtual environment is created. Let's start off by activating the virtual environment. So I'll run source custodian bin activate. My virtual environment's active now. I'm going to start off by installing C7N, which is the Cloudcustodian core package. I'm going to use pip to do that installation. It's just fetching the packages from PyPy and installing them on the virtual environment. So that's done, complete. Now if I just clear this quickly and run pip freeze, you'll be able to see all the packages that are available in my virtual environment. We've got version 0.9.1 of C7N. Now before proceeding further, it'd be a good idea to install the Azure dependencies for Cloudcustodian. There's a separate package available. For Azure, we could do that by running pip3 install C7N_Azure. Now this will install the complete Azure package for Cloudcustodian, as well as any dependencies and sub packages that may be required. I'm gonna let it roll through and install all the dependencies that it has here. Quite a lot of dependencies, I must say. And once it completes, I'll have it run pip freeze so I can see all the list of packages that are in my virtual environment now. Okay, almost there, I reckon. Almost, yes. Come on, you can do it. Setup.py and done. Great. Okay, perfect. So let's clear this and run pip freeze. Okay, we've got quite a few packages now, but you see C7N and C7N Azure. Cool. Let's clear this. Okay, so we could see the command line utility available for Custodian. I could do that by running custodian -h, and I can see it's got a few commandlets: run, schema, report, version, and validate. And you can pick up any one of the commands and again use the -h flag to see more details on how to implement this. The schema command looks interesting, so let's sort of start off exploring with that. By running custodian schema and the cloud, we can see all the available schema elements now and all the components. So for example, we can see AWS Lambda, AWS IoT, Glue, Glacier, EKS. So that the element after the dot is really the component. If I look at AWS.account, be able to see the actions as well as the filters that are available at the AWS.account level. So let's just run custodian schema AWS.account. As we run that, we can see these are the filter criteria we can use in our policies when we're scoping it at the account level. Okay, let's change gears a little bit and look at the schema for Azure. And as you can see, these are all the different components in Azure that are available to us. So let's look into Azure.vm. And as we can see in the schema, there's additional actions and filters for us to work with in our policies. As you can see, there's quite a rich level of documentation available on the schema elements for both AWS as well as Azure. I'm going to now start to apply some of this. And in order to do this, I'm going to create new directories, one out and one policies. Policies is the directory where we will write the actual policy files in YAML. And when we run the policies, the output would be generated in the out file. If we look at the command line switch again, run is the actual command line switch we need to use to run the policies. One great thing about Custodian is it allows you to export the schema that we've looked at into a YAML or a JSON based output, which can be imported into Visual Studio Code, and then that starts to give you IntelliSense support as you start to write the policy files themselves. So what I'm going to do is I'm going to run this command to generate the schema, and as we open up Visual Studio Code, you see out and policies both are empty. We're going to start off by creating a new policy file, and let's see if we get IntelliSense support in there. So the intent of the first policy is to inspect my AWS account for S3s that don't currently have encryption enabled. Now you have to start off your policy files with the policies keyword. There you go, we get IntelliSense support thanks to the schema we generated before. Let's quickly give the policy a name. Now within the policy schema structure, we have to use the name tag, and then in addition to that, we need to specify which resource this policy applies to. Now clearly we're targeting S3 here. We can give it a description as well. S3 buckets without encryption set to required. Okay, as we previously saw when we were exploring the schema, that we have access to filters and actions. So I'm going to use the filter for type no encryption statements. So any S3s it finds, it will filter those out to those S3s that don't currently have encryption statement enabled on them. And after that, we can apply an action. And the action in this case would be to simply attach encryption onto those buckets. So for purposes of demo, I'm going to take the action out because I don't want to change my AWS account just now. So I'm just going to remove that statement. What we're going to do now is first validate whether the policy file we've generated is even valid. And we can do that by using the Custodian validate switch. So we can type Custodian validate and then specify the path to the policy that we want to validate. And in this case, that'll be .policies / AWS S3 bucket encryption policy absent.yaml. As we can see, our policy is valid. Now I've already installed the AWS CLI. I'm going to use the AWS configure profile command to create a profile for my AWS account. You see I've specified the keys and the secret there already. Now that I have my AWS account set up, I'm going to use the custodian run command to execute the policy that we've just written up to inspect our S3 buckets. Now what's really great with Custodian is that the run switch comes with a dry run mode, and the dry run mode excludes any actions that you may have defined within your policies. So the purpose here is to be able to run the policy and execute the filters to see a subset of the AWS components that would be impacted, but not necessarily run the actions against those. As you can see, we have successfully run the policy, and we've seen that it returns a handful of resources which are sort of filtered by running this policy. Rather than read the output, what I'm going to do now is I'm going to show you the output file that it generates. As you can see, it generates a JSON output which has the values for the resources that are covered through this policy. Now, Custodian also provides us a report switch that we can use. So I could run the command with the report switch, which basically takes the output from the previous execution of the command and renders that in a more user-friendly format on your command line tool of choice. In this case, I'm going to run the command with a format as a grid switch. I have options to format it as a grid or as a CSV, or just simply see the JSON if I want to do that as well. There you go. So these are all the buckets that I have within my AWS account that are currently not encrypted. Not great, and if I choose to, I could apply the action to have this course corrected as well. Next, let's look at another policy. If you've used AWS accounts previously, you would be familiar with the concept of soft limits. Every account comes with certain soft limits on resources. For example, by default, you can have up to 50 stacks that you can deploy to. If you exceed that limits, you have to raise a ticket to AWS support, and they'd happily increase that limit. I think a lot of these limits are put as a safeguard to prevent you from accidentally stacking up a huge bill. Some of these limits also cover, for example, ECS, where you could have only 50 services in ECS running. Again, a soft limit to protect you from running a lot of services, which could stack up a massive bill for you. So I'm going to create this policy for inspecting the soft limits that I have within my AWS account and the threshold coverage of consumption against those limits. I've currently set the threshold to 50. So that means if I have consumed 50% of the CloudFormation stacks that I'm allowed to deploy to, then this will alert me, in which case I could extend this policy to set up an action which can raise an automatic ticket to AWS support for those specific items and have them extended by whatever percentage I choose, 25, 30, 40, 50. So we can see that our policy file is valid. I'm going to execute the command now in a dry run mode and have it generate an output which we can then inspect to see what the output looks like. So I'm going to run this again against one of my other AWS accounts, which I class as pre-prod. It's just taking a bit of time to run because it's got about 50, 60 different checks that it performs under this policy. Okay. So we can see it says count 1, which means there is at least one limit on the account that we're close to breaching. I think in order to best visualize this, what I'm going to do is I'm going to take the JSON file that it produces and render that in a JSON grid online tool so we can actually inspect the table and see more details on it. As you can see in the result there, this is the section where it's highlighting that I am breaching my CloudFormation stack soft limit. Okay, so let's quickly open up the folder where we have our JSON output file generated. I'm going to open this up in Visual Studio Code. Let's copy this file across. Paste the JSON and have it generate the grid. Now the first section, which is the service limits, shows you the service limits I've breached, and the table on the right has all the checks that are performed under this policy. So these are all the checks that are performed. It performs checks on EC2 spots, and again, all of these are soft limits, but unless you hit the soft limit, most of the times you don't even realize. And then even though the process to get these corrected from AWS support is quick, it could still take 24 to 48 hours for them to action it, and then the overhead of having to wait for that period while you might have an urgent need to deploy something, right? Again, more examples of the policy inspection just to give you a good idea around it. Okay, so we've covered quite a bit of ground with AWS. What I'm going to do now is I'm going to just wrap this up and start to talk about Azure, because there are quite a great number of policies that we can use with Azure as well. First off, I'm going to set up my Azure account. So I've installed the Azure CLI that is available for Mac. So I've got it configured on my terminal now. If I run AZ help, you can see all the subcommandlets that it offers you. AZ account is one that I'm going to use now to log into my account and see a list of all the subscriptions I have. So if I run AZ account list, it gives me a JSON response back of all the Azure subscriptions I have configured against my identity. I can also run this AZ account command with a query filter and choose the output type. I'm going to choose the output type table, and I'm going to run a query which will allow me to filter the results out to only the column name, so I don't show you the grid of my subscriptions there. So these are all the Azure subscriptions I have access to against my ID. I've configured my dev test account where I've provisioned some resources, so when I run the policies, you see some meaningful output against it as well. Okay, so let's clear this and switch back into Visual Studio Code and create some new policy files that will apply to Azure. Now, one of the big bugbears with Azure resource groups is people tend to create resource group to combine the resources that logically can be grouped together, but people often, after deleting the resources, never clean the resource groups out. What that leaves you with is a lot of skeleton resource groups that just lie hanging around in your subscription, but they don't really have any resources under them. I mean, it doesn't cost you anything, but from an administration point of view, it just is a bit of a nightmare because it leaves permissions and a lot of open endpoints within your subscription. Give this policy file a name. I'm going to call it rgremoveempty. I've added a description. This policy really applies at the Azure.resource group level, and within the Azure.resource group schema, we have filters that allow us to scan for empty groups, as well as apply actions. An easy example of an action is type delete, which would basically identify any empty resource groups and simply delete them. Again, for purposes of this demo, I'm going to remove the action because I don't want to delete these resource groups just now. Okay, so first off, we can quickly run the validate command to inspect whether the policy file we've created is syntactically correct. And we could do that by running custodian validate, point to the path of the new policy file we've created. So I'm just going to do that. Run this, and yes, the policy file is valid. Next up, I'm going to run custodian in dry mode against my AWS account, which I showed you previously, which I've configured as the default subscription on the command line. And when I run this, it basically does the authentication against my Azure subscription first, and then goes through the policy to inspect the resource groups. You know, just for reference, I've got about 800 resource groups set up in that Azure account, so it taking a bit of time, and net 15 seconds. I don't think that's a lot of time to identify 71 empty resource groups. And again, I can use the custodian report command to render the results of the last execution of that command. So in this case, I'm going to use the format simple, which basically just returns a list of all the empty resource groups. Okay, and it shows me the locations they're provisioned in as well. Okay, clutter, I would say. All right, so I'm going to show you another policy with Azure, which again is quite common to anyone using Azure. Is, you know, we would deploy virtual machines and then we would delete virtual machines, but sometimes in the process we would have network cards that are just left orphaned, hanging into our subscriptions. And unlike empty resource groups, orphan NIC cards have a cost. So, you know, in your Azure bill every month, if you have empty network interface cards, you would be charged a price for them, whether they're attached to a virtual machine or not. And same's the case with data disks, right? People tend to delete VMs but leave the data disks lying around. And storage, while it's cheap, it's still relatively expensive, and having to pay for those resources is what ultimately accounts for the 11.6 billion wasted, sorry, 17.6 billion wasted cloud spend that we've talked about previously. So I'm going to use the Azure.network interface resource. I've added my filters, which will basically look at the key for property.virtualmachine. And if a network card doesn't have the property.virtualmachine associated value to it, and that value is null, then that simply implies that that network card is not associated to a virtual machine. Okay, so that policy file is valid. Again, I'm going to run the command in a dry run mode to see the filtered subset of items from within my Azure account, which would get picked up through this policy. Okay, so it's done the authentication. It's found about 106 network cards that are currently unassociated. Again, even if they were charged at £1 per day, that I'm paying quite a lot of money for them for no good reason. Okay, so another one that I want to quickly cover is public IP addresses. Now, a lot of the enterprises that are setting up Azure for private use and attaching them to their private data centers are setting up networks and subnets and NSGs with policies for internal only traffic. And they tend to work really well if you issue private IP addresses to the VMs. So any public IP addresses attached to the VMs become a no-no because they give you an entry point into the network. And that's not encouraged. So what you really want to have is a policy that can at scale inspect all of the network cards that you have attached or unattached to VMs and look for the property key of public IP address. And if you find the property public IP address, then that simply means that those VMs have been issued public IP addresses. So I'm going to limit this to resource azure.vm, set the type to network interface, and look for the key properties.ipconfiguration.properties.public-ip-address.id and check for a value of not null. So switching over to terminal, I'm going to run the policy directly in a dry run mode. Let's see if we can find any resources within my Azure account that have been issued public IP addresses. And great, I have got 3 VMs there that have public IP addresses. And again, having to do that in an Azure account with 1600 plus VMs deployed can be a bit of a nightmare. Having to run that as a continuous process can be an even bigger pain. So being able to write a policy this simple to go through hundreds and thousands of VMs across multiple Azure accounts to pick out any VMs that have been issued public IP addresses, I think is fantastic. Okay, and then that's just looking at the results in a report format. Okay, so I'm going to give you this one last policy in Azure. And this one, I think many people would find useful. And again, this is just to give you an idea of what you can perform with virtual machines. So sometimes we tend to switch off virtual machines, but not delete them in anticipation that we may need those virtual machines at some point. And while we don't get charged for compute, we still get charged for the other resources like the network card, like the storage. So it's useful to have a view of the number of stock VMs, and we can write this simple policy which basically targets the resource azure.vm and does an instance view check on the key status code. And if the status code is not empowered, then that just simply implies that the machines are in a switch off mode. And you could run this policy the other way around, where you basically inspect the number of virtual machines that you think should be switched off at a certain time of the day, And if the results come out any different, then you can drill in further to identify why those virtual machines are not switched off. So a clear example would be, if you anticipate 50% of your fleet to be switched off over the weekends, then this policy can run and inform you of the actual number of virtual machines that are still that are still actually in running mode. And then you can look at the diff to work out, why some of those virtual machines haven't switched off. Again, I'm going to run this policy in a dry run mode. It's working through about 1500, 1600 VMs in that account, so I do anticipate it's going to take a bit of time to work out the result set. Still going. Another thing worth mentioning is you can always run the custodian commands with a -- verbose switch, and it will give you the outcome and the output of the commands as it's being run as well, which I think sometimes is useful, especially if you're running this again against a big resource set. You sometimes think whether the command is running or it's holding up for something or something else. Actually, I'm going to give you one bonus policy now, which is the underutilization of resource. Again, that's a common cause of overspend, is we tend to over provision infrastructure than our actual need. So one great thing with Custodian is that it's able to leverage Azure Monitor to perform queries against it and identify resource consumption. Say if you had a SQL Server instance which is only 10% utilized, it's clear evidence that there's merit in downsizing it to a lower SKU, but you wouldn't naturally be able to identify that if you weren't looking for it. And again, you could use Azure Advisor, but wouldn't it be great if you had a policy which was constantly inspecting that and informing you of that metric? Even better, you could extend the policy to add an action block, which basically just goes and auto-corrects that. So as we look at the filter, what we're building out here is we're applying this policy to the Azure.SQL Server resource, and we're saying go filter on the basis of metric. The metric name that I want you to filter on is DTU consumption percentage. Look at the aggregation type average. If it's less than 10% over the span of last 24 hours, then filter that down to a subset of resources. And again, I'm using the database resource ID is equal to star to say just run this across the whole subscription. But again, I could make this more specific if I wanted to do that. So I'm going to run this policy in dry run mode and just point to the policy YAML file path. Okay, let's run this. Now I've implanted an error in there out of choice because I just wanted to show you that if you run the policy and the policy is incorrect, you still get a lot of good feedback on the command line run execution command, which will inform you where the potential problem could be. I just simply misspelled threshold, so I've corrected that now. If I run this again, it does a authentication and it comes back with a count of 8 SQL Server instances in that subscription, which are massively underutilized. Yeah, massively underutilized, literally just 10% utilized. And if you may question that, hey, maybe they're underutilized just during the course of off-peak hours, then you could leverage some advanced techniques with auto-scaling to probably tone down their size during off-peak hours. Again, these are the opportunities that are worth exploring and exploiting in certain cases to make the most of cost optimization within cloud. And these are the specific database instances. I can see the instance name, the resource group, the location, and even the version of the SQL being used. Okay, when we've covered quite a few policies, I'm going to show you the integration that is available out of the box with App Insights. I've set up an App Insights instance. As you can see, I've got an instrumentation key now. I'm going to run the commands that I've been running, but I'm going to run them with an additional switch called logger. And when I run it with the logger switch, I have the option of passing the path to an Azure App Insights instance. So in this case, in this command, I'm simply going to additionally add the logger switch and then use Azure : / and append the name or the ID of the App Insights instance that I've created. And as I do that, all the logging that is generated by running this command is basically shipped out into the App Insights instance. Now imagine having to run this through a pipeline because we're running in an interactive mode here, but hey, what if you wanted to run this overnight, all the policies, and you just wanted the results to go out into an App Insights instance, right? And then that means the logs coming into App Insights, you could set up some streaming, some actions on the back of that as well. So this allows you a nice, neat integration back into your cloud-based features to extend what you could do with the outputs of it. And App Insights is just one example. I could actually decide to integrate this with Azure policies themselves or Azure Security Center. In both the cases, it offers some fantastic integration out of the box. So just flipping over to App Insights, you can see that it successfully logged the output of the commands. I could also optionally run the command with the -m switch, in which case any metrics produced out of running the commands are also added as custom metrics to App Insights, which I think is fantastic as it gives you great charting and alerting capabilities. We can come in and simply select the metrics group type as custom, and it gives us the additional options of resource count. So I could just check the count or min, max, average, and start to filter out the results and create some charts on the back of that. Just to quickly show you, there's a good level of documentation available for AWS as well as Azure. A lot of sample policies you could reference with the policy documents being walked through and with a good level of examples being provided there. Okay, well, I'm gonna now show you how to create a pipeline using Azure Pipelines, which will allow you to run these policies in a non-interactive mode. I'm gonna try and keep the example simple so you could understand the building blocks that we need to put together. So first off, I'm gonna create a new Git repository. I'm gonna call it infra.policies. You've seen me working on my local environment, so I've got the policy documents written up, but I don't have a Git repository yet, so I'm going to initialize a Git repository within the folders where I've been creating the policies. I'm going to add the policies folder, stage the changes. As you can see, they're successfully staged. I'm going to commit the changes now to my local Git repository. Let's just call it init policies as a comment. Now I need to associate this local Git repository with a remote. So I'm going to associate this with a new remote repository that we've just created and now push the changes up to the server. Okay, so at this point, the policy should be available on the server. We can see that they're showing up in the policies folder. Great, so next I'm going to create a pipeline. So I'm going to go over to the Azure Pipelines. Now we've been talking about Azure YAML Pipeline. So if you haven't seen some of my earlier videos on Azure YAML Pipelines, do that because that's going to give you a bit of foundation. I'm going to select the repository. In this case, we're going to choose the infra.policies. I'm simply going to select a starter pipeline template so we have a skeleton to work with. Let's just give it a name. Let's call it AWS Policy Inspection. Okay, so I'm gonna just save the pipeline as is without making any changes. Let's just give it a commit message, call it Policy Inspection Pipeline. Okay. Just gonna rename that to aws.infra.policies. Okay, let's run this pipeline. Now at this point, this pipeline doesn't have anything beyond it being associated to our Git repository. So at this point, it's just getting the Git repository, checking it out, and that's really it. But we'll iterate through it to see how we can get it into a state where it can actually execute the policies themselves and provide some meaningful results on the back of that. Okay, so I'm going to remove the default steps that came in with the out-of-box template, and let's just write some pseudo steps on what we think the flow within the pipeline should look like. Now, because we're using Python here, we need to make sure that we can configure this pipeline to first set a version of the Python interpreter to be used, because locally I'm developing with 3.7, and that's the version I've tested my code in, and it'd be meaningful and sensible to run the same version of Python on the server. Next logical step would be to install AWS CLI and then run and install the C7N packages. Now, if we want to run the Azure policies, we should also install the C7N_Azure package as well. The next step would be to configure an AWS context. So we would have to inject our AWS credentials into a profile and make them available. So any commands that we run pick up that context when they try and execute against AWS. And naturally, the next step would be to simply run the Cloudcustodian policy, and finally, any output that gets generated on the back of running that policy would be good to upload that as an output to the pipeline itself. Okay, so that is, I think, a good flow of what we intend to do. Okay, so now that we have the steps figured out, let's start filling in the blanks. We could use the out-of-box task that is available to us to set the default version of Python. So I'm going to use the task called use Python version. And if I show you the assistant for this, you see it provides us a very simple interface which allows us to specify the version of Python. Now, the Ubuntu latest agent has a lot of these Python's versions installed by default. You could look at the help to work out which ones are installed. As long as you pin the version of Python to be used to a major version, you're fine, because if you stick to minor versions as well, the minor versions tend to change, which will break your pipeline because they're not necessarily going to be available on the agent unless you choose to install them as well. I'm going to use the script task to basically write out the commands that need to be run to install the pip packages. But before I do that, I'm going to simply upgrade pip and then export the path of pip so I could directly invoke it rather than having to refer the path to invoke pip. So we're just going to need two packages. We're going to need the AWS CLI, and then we're going to need C7N itself. So pip3 install AWS CLI and upgrade it in the process, and pip install C7N upgrade. So that's done. Moving on, set AWS context using AWS CLI. So I'm going to hold off here because I first need to actually get the credentials into the pipeline before I can set the context. But before I do that, let's just run the steps we have and see whether we're able to install the packages using pip and have the default version of Python set out in that pipeline or not. So the pipeline's now running. Let's just wait for some feedback. It's successfully set the Python version, and it's going through the process of setting up. Yep, I can see there it's installed C7N. It's now installing AWS CLI. That's done as well. So I'm just going to click on install requirements once to show you the results. Yeah, you can see AWS CLI has been successfully installed. Okay, so let's go back into the pipeline section. Within the pipeline section, you have access to library, and library is a collection of key values that can be encrypted should you choose to. So I've set up a library for storing my AWS access key and access key secret, as well as the account ID. So I don't really need to write it up as a clear text variable within my pipeline. I can refer the variable group that I've set up within the pipeline, which makes it available to the pipeline, and choose to access the specific encrypted variables within specific tasks. So that's exactly what I'm going to do. I've set up a PowerShell task, and in this one I'm going to run the AWS configure, set the AWS account, set the AWS key as well as the secret. Just configuring that, bear with me here. Okay, simply copy that and change that to AWS secret underscore access key. Don't need the ID in there. Yep. And then let's just copy that. I'm going to change that to default.region. So when I create the context, I'm passing this as a default that it should refer the region, and I've specified the region in the environment that I've created, which I've linked into this pipeline now. So this will be available to the pipeline when it runs. And I sort of need to use env because I am passing encrypted values, and when you have encrypted values in your library, in order to make them available to the task, you have to inject them through the env switch. Okay, so that should hopefully set up the AWS context. Now the best way to test this is basically then invoke something in AWS. A simple command I could think of is I could just simply run AWS space S3 space LS, which should list out all the buckets, all the S3s that I've got within my AWS account. So let's just save these changes that we've done to add the additional context and the test command, and let's just run this pipeline to see whether this bit works or not. Okay, so that should have triggered the pipeline. Let's just open it up and look at the output. Okay, install requirements. Just working through that at the minute. Still going, right. AWS credentials, context set, and that successfully run our test command there. If I click on it, yep, that's the list of all the buckets in that AWS account. Perfect. So the AWS context setting is working, and that's quite an elegant way to do it, because if you have more than one AWS account, you could start linking up multiple variable groups and start mapping them out to individual tasks or stages or jobs within your pipeline. So now I'm going to run the real command that I should be running in order to invoke Custodian. Now I'm really just showing you an example of running one policy, but you could structure it differently to run several policies. So Custodian run, I'm going to run this in dry run so we can see the output on the pipeline execution screen itself. And then -s allows us to specify the output directory. In this case, I'm going to use the predefined build variable called build.artifactstaging directory as the output placeholder for where the output files from that policy execution should be generated, and then I'm simply pointing to the path of where the policy file would be on the server. And then I'm running the follow-on command for custodian report, pointing to that output location and that policy file itself, which then will print the output of that policy in a grid format on the pipeline output itself, which would just make it easier for us to see the outcome of the policy execution. Okay, let's just give it a meaningful display name, which is Invoke Custodian. Yep, I am being very pedantic here, but I'm going to go up and amend my pseudocode as well. I'm going to call it Invoke Custodian policy Okay, so just the last step now. We would like to upload the output that the policy generates to the pipeline. For this, I could use the publish build artifact out-of-box task and point it to the build.artifact staging directory, which is where we will be generating all of the outputs from Custodian. Okay, so that setting seems correct. I'm just going to click add. And then YAML magic, I'm just going to indent this task out so it's aligned, and that wiggly error should go away. Perfect. Okay, that looks good. Okay, well, I'm going to save the changes now. Just give it a meaningful commit message, invoke custodian, and upload results. And with that, the pipeline should have triggered. Okay, just waiting for an agent to be assigned. Okay, an agent is assigned, so it's just going to work through the steps now. Check out the code repository, set the Python version, install the requirements of AWS CLI, C7N. And again, if you haven't used Azure Artifacts, you should, because that would just make these packages available that we're installing using public PyPy in Azure Artifacts, which means the following installs of these packages would be way quicker than that's currently happening. So the AWS context is set using the credentials we've set up in the library. It's invoking Custodian, and it's printing out the results. Perfect. It's all successful. So if I just now click on invoke Custodian, you can see it's run the command and it's actually printed the output in a report format as well. So if we click on the details, we can see one item's been published and the drop location of the actual policy output has also been attached to our pipeline. So we've got a good audit trail of the executions. Great, so that's the example of running this in a non-interactive way in the pipeline. And if you're interested, that's the actual YAML file. Check out the section below. I'll leave a link to my Git repo as well. And that's it from me. Thank you for watching. Don't forget to subscribe, and I'll see you in the next video.